Do the folks coming in see the chat, or is that only panelists?
It's only panelist.
There is a way we can chat with the audience, I think, right? But they can't respond to us. So you have to you could select everyone, or if you do hosts and panelists, then it's that. Yeah.
I see the host and panelists there. Yeah.
I'm just trying to remember the order of speakers here. I have the agenda in front of me.
Yeah.
Am I still second? Shyla first?
It goes Shyla, then me.
Okay.
Then I'll pass it to you, Joe.
Okay.
Then
Thanks.
Katie, Teresa, Emily, Matt.
And I'll go ahead and start sharing my welcome screen. Can everyone see it? So let me know when you want me to kick it off. Oh, okay. I'll go ahead and start then. Hello, everyone, and welcome. Thank you for joining us today. Before we begin, I would like to just take a few minutes to talk about iDigBio and the work we still have going on. As many of you know, iDigBio will officially conclude in 2026. But for the past 15 years, iDigBio has made an incredible impact supporting research, collaboration, and innovation on a national scale. This isn't a moment of sadness, but one of transition. We're proud to pass the torch to the broader community, confident that the mission of advancing biodiversity, digitization, and discovery will continue in capable hands. Oh, there we go. So before we before we dive into today's presentation, let me give a quick overview of who we are, what our mission has been, and the exciting work that's still happening. iDigBio began 15 years ago with the support of the National Science Foundation and the vision of its founding leaders. Over that time, we've made tremendous strides together as a community, and our shared efforts have helped shape the future of biodiversity research. At its heart, iDigBio works to make biodiversity specimen data widely available and useful through digitization, training, open access, and creative new applications. And while iDigBio as a project will eventually close, our mission and the data the community has generated will live on. Thanks to contributors from over 1,000 biodiversity collections across 350 institutions in the US, the iDigBio portal now hosts nearly 150 million specimen records and 65 million media files from 2,000 datasets. These datasets will remain available long after iDigBio, continuing to serve researchers, educators, scientists, and the public. And we're not done yet. As we move towards the conclusion of our project, we still have new initiatives on the horizon. One of them is this new webinar series, which highlights protocols, practices, and strategies to ensure long-term continuation of collections, digitization, and data mobilization. The collections community is well positioned to sustain this important work, and we're excited to support the transition. Building on the iDigBio's legacy of collaboration and innovation, today's webinar will emphasize the importance of sustaining digitization efforts and ensuring that biodiversity data will continue to be mobilized to GBIF and other aggregators. Making data widely available through these platforms is essential for advancing research and education and discovery. It allows the work of individual collections to have a lasting impact on the global community. So before I hand things over to our speakers, just a quick reminder, as with all iDigBio webinars, the chat and mic functions will be disabled, so please post your questions in the Q&A feature and we'll get to many as time allows. Thank you for your understanding. So without further ado, I'll hand things over to Libby to kick things off.
Thank you so much, Shyla. Welcome, everybody. I will go ahead and share my screen now. Hopefully that looks all right. If I could get a thumbs up from somebody somewhere. Or a yes.
Can't see it
Don't
yet.
see it yet.
Can't see it yet. Okay, let me try that.
Perfect.
Good.
Got it.
All right, thank you. So yes, thanks so much for joining us today. I'm going to build off of some of what Shyla mentioned, kind of taking a little bit of a peek into the past to show you just how far we as a community have come, and to then hopefully set us off on a path to the future. So iDigBio has provided a foundation for community building, data ingestion, and resource creation and dissemination, among other things. And many of you have been a part of this with us through the journey. So looking at community building, this was a lot of fun for me to put together, actually. It is just a little bit of a sporadic sort of touchdown into some of our past events, but really there are hundreds and hundreds of these to choose from. So I just kind of chose a few that I think demonstrate the magnitude of community that has been built and grown over the course of the tenure of iDigBio. So we've had a whole bunch of summits over the years, bringing together folks who have been involved with some of our TCNs and our PENs, our thematic collection networks, and partnering folks. And so here are some images from our summits. As you could see, it's a really impressive group of people here. Maybe you see yourself in some of these images too. We've had tons of workshops in all kinds of places, near, far, as part of conferences and standalone workshops, and usually with some kind of digitization focus or data use focus or education focus. And we've tried to cast a really wide net for these topics as they relate to the issues that you've identified with your digitization process. So we've been, as I said, near and far to do these things, and as such have built communities locally, regionally, at the state and national levels, as well as internationally. And we've tabled at events. We have iDigBio. Many of you have stickers on your laptops and water bottles and whatever, thanks to our outreach efforts. And this has all been a part of the community that we've built, that you guys are all a part of. A more recent one from just about a year ago in Japan. And I think this really speaks to the strength of the community that we will be able to support going forward as well. And you guys all remember the COVID years too, when all we saw were these little profiles of each other on the screen. And we're still here, which is nice that we have that option as well as in person again. So in addition to the building of the people side of the community, we've also done a lot for data ingestion and making sure that all of our biodiversity data are mobilized to the richest extent possible. So we've hosted all kinds of different workshops related to imaging and data ingestion and transcription and all the various aspects of digitization and data mobilization, hopefully giving folks some hands-on opportunities and the ability to interact with each other, to interact with experts, to interact with folks who are just starting off and maybe in a similar position as other folks, and to present all sorts of options given different budgets, resources, person power, etc. And as a result of these efforts, and like I said, iDigBio is only providing the opportunity for folks to be able to do this themselves. We are just one piece of this. We've created a portal that now shows 148 million records, more than that. So it's an impressive feat. These next couple of slides are ones that were put together by Jose Fortes, the PI of our cyber infrastructure domain. So I'm going to kind of take a sec to read these. iDigBio will continue to operate until a year from now, until August 2026, and this includes improvement and maintenance of existing services. Ingestion of new data will cease no later than June 2026. So if you're actively contributing data to iDigBio, you might want to have that date in the back of your mind. And providers are already providing data to GBIF. Right now, we have about 98% of iDigBio already in the GBIF database, so your data are safe. We will do progressive decommission of content and services, and this will be coordinated among everybody involved with the project, from the PIs and providers and users, and of course, the National Science Foundation. And that will be completed by the summer of 2026. continued pursuit of sustainability avenues for all or some services in cyber infrastructure. While it's unlikely that the full suite of iDigBio activities and domains will be supported, we are still actively looking for ways to support various aspects of what we do. So we hope to sustain as much as we can, but the scale of that and exactly how it happens, it might be a little more piecemeal than you are currently a part of. And so then going beyond 2026, ACES will continue to carry out research on biodiversity informatics, and it could be funded by other sources outside of NSF, and will include collaborations with biocollections community, all you guys, and transient prototype biodiversity data services like iChatBio. If you haven't had a chance to explore iChatBio, I recommend that you do. There's a link directly on our website on idigbio.org, although you could also just go to iChatBio and find it. The ACES folks are actively seeking funding sources and partnerships to continue various of these activities. So in addition to the sort of the community side and the data side, we've also, iDigBio has also been working to create resources and disseminate them for all the various aspects of digitization and data mobilization. So thinking in the longer term, there have been so many different working groups and outcomes from workshops and conferences and whatever that have been compiled into articles, peer-reviewed articles, and other resources that I'm stating are living in forever resources, forever being a hopeful term, I guess, for some of these. But if you look at our Google Scholar page, you could find a lot of the peer-reviewed articles that describe some of these activities, especially research use of iDigBio data and some of our technical advancements. If you're interested in some of our educational resources, cubesub.org is a place where you could find not just things related to iDigBio, but all sorts of educational ways to use biodiversity data. And similarly with the workflows, you could find those published online too. And these are places I'm mentioning that are outside of iDigBio resources, as the last couple of slides outlined. Some things may or may not be available a year from now. So this is kind of pointing out some ways that you could continue to find this stuff forever. We've also been a part of a lot of conferences, presentations, and symposia, and all of that. So feel free to dig into those archives as well when you're looking for iDigBio information for the longer term. I think those are great resources to find the resources that have been created over the last 14 plus years. And one of the big pushes in this final year of iDigBio is this webinar series where we are bringing together sort of the who's who and the what's what of the iDigBio community. And these are people who you might want to connect with now or to think about connecting with in the future, similarly with the tools, services, and software and all the additional resources that they'll be presenting. We're taking this opportunity to kind of do a state of the state and where do these things stand now, who's doing what, and how are they doing it, and how can the community become involved with some of these resources. Also ways for folks to interact with each other. So please do take advantage of the full webinar series. You could find this on our website as well on the iDigBio wiki. And in today's webinar, what we're going to do is we're going to hear from some tools and services that you may or may not be aware of. You may or may not be involved with them now, but they can and are already providing some services that might be important to you, especially after iDigBio comes to an end a year from now. So just kind of thinking about ways that they engage with each other, with iDigBio data, with potentially your data if it's not already. So that's our impetus behind today's topic, is demonstrating some tools that you might see a way to take advantage of with your own collections and collections data. So as I said, iDigBio's been really busy these last 14 plus years, and we've put a lot of pieces out there. And as a community, we've all been able to come together in these various ways. And I think we can only go further into the future productively and in a way that addresses some of our major societal issues together with the help of biodiversity data and all the work that you are doing. So thank you so much for being here. And without further ado, I'm going to pass it on to Joe Miller from GBIF.
Hello, everyone, and thank you, Libby. Getting my slides here. I just want to start by saying how, can you see my slides, please?
Yes, we do. That looks good.
Great. Thank you very much. How immensely proud I am of iDigBio and to consider myself part of it, and just the wonderful work the U.S. community has done over the past 14, 15 years, and it's wonderful to be part of it. My name is Joe Miller. I'm the Executive Secretary of GBIF, the Global Biodiversity Information Facility. I am an American, and it's always nice to speak to an American crowd, so it kind of makes me feel a little homesick. So it's nice to speak with you today. I want to give you an overview of GBIF and how it relates a bit to U.S. collections and what we as a community are going to keep doing things together as we always have, and to really make use of the biodiversity collections to have impact on science and policy. So today I'm going to talk about GBIF, iDigBio, of course, and then, of course, GBIF US, the US node of GBIF, which I will explain. So GBIF, I like to describe it as two things. It's a group of people, and I hope everyone on this call, after this meeting, feels like they're part of GBIF as well, because we all feel like we're part of iDigBio. Well, I hope everyone feels we're part of GBIF as well, because we're all working towards the same goals. And I took a quick look at the participant list, the attendee list, while Libby was talking. I was delighted to see that I don't know many of those names on the list. So that tells me there's a new community being very active in iDigBio. So it's wonderful to see it and welcome you. I'd like to welcome you to this talk. So GBIF is a network of data publishers and nations and participants. We have national participants in 67 countries and also have over 40 associate participants. Associate participants include iDigBio and the Symbiotic Support Hub, which are both represented on the panel today. And really together, we are a community that publishes and shares data and uses data, because we're all concerned about biodiversity. We want to make an impact. And really the networking amongst these communities is really what drives iDigBio, and it's what drives GBIF, and it's what we really need to preserve our biodiversity. But we're also a very high throughput infrastructure. Every second, 13.6 new records come to GBIF. And that data is a little bit old. It's even a little bit higher now. So we're a very high throughput data facility. For example, last week, we had 40 million new records come from one environmental DNA project in Australia. So we have to be a very strong infrastructure in order to manage this type of data. But as a reviewer of us mentioned, we're the most comprehensive, openly available, application agnostic, easiest to use, modern access point to digital species occurrence data. And we're much more than specimen data. So I just want to make that point in a little bit in the upcoming slide. So we do more than specimens as well as other types of data. So have we been successful? I think so. This is a heat map of this occurrence density. And I just want to show you a couple different time points from 2014 on to 2017, and then on to 2024 last year. So as a global community, we are sharing more biodiversity data. We have more biodiversity data available for actions. And this is quite critical because we have lots of biodiversity issues that we need data to help us give us a path forward. So this is our GBIF by the numbers slide. And I want to make a couple of points here. Just last week, I think it was earlier this week, we turned over 3.5 billion occurrence records in GBIF. That's B with a B for a billion occurrence records. We now have over 2,500 publishers in 146 countries that share data with GBIF. I didn't update that, but we have 67 country participants, and we integrate over 115,000 different data sets into the GBIF index. I'll talk about this a little bit later, but we have this unique DOI citation tracking system. Every data set that comes into GBIF and exits GBIF gets a DOI, and we ask the community to cite that DOI when you publish a paper so that we can see the impact of data sharing. And currently we have over 13,000 peer-reviewed publications that have cited specific GBIF mediated data sets. And many of those would be US papers that cite data from the United States. So I'm not going to go into detail here, but I just want to show you the breadth of what we do at GBIF. We'll be 25 years old next year. the reality is that GBIF is the output of the US thinking. It was incubated in the National Science Foundation as an idea to integrate data providers across the globe with the coming of age of this internet thing. How can we take our individual databases, put them together for greater benefit? And that's what GBIF is all about. We started out with the collections community with phase 1. We really are kind of in the peak of the phase 2 now, which is observations. Observations make the majority of our data, citizen science observations. The biggest data set in GBIF is eBird. iNaturalist is, I think, the 4th or 5th largest data set in GBIF. So large flows of citizen science data. But right now, we're kind of at the beginning of the 3rd phase, which is machine-derived data. Machine-derived data, meaning data from camera traps, acoustic monitoring, environmental DNA sequences, as I just mentioned. So we are an infrastructure that brings together all these different types of evidence of life on Earth. We use the standards that you as a community make through TADWIG and other standards bodies, and we implement them in our infrastructure in the global index and provide that data out through gbif.org, but more commonly through the API. So if you use our GBIF or PyGBIF, you're accessing a GBIF that way, and these data, it's certainly a wonderful way to use the data. So with the DOI tracking system, we can track the data use for policy and research. And we know and we have a staff member who goes through all of those papers and categorizes them to ecology or climate or human health so that we know exactly how the data is being used. And then we also know that the data is being used for policy. And this is, I think, very important. If you share data with iDigBio, you share data with GBIF, I'll guarantee you that data is being used for global policy decisions, such as the IPBES global report on invasive and alien species from a couple of years ago. GBIF data, iDigBio data, your data was used in that report. So I'd like to brag here a little bit about the US, because US traditionally is the largest data provider of data in GBIF. Always is. This year, it's ranked number 2 at this stage, but I'm sure this data slide is out of date because of some recent data flows that have come into GBIF. So the US is the largest data provider to GBIF, with last year over 158 million records coming to GBIF. That 17 million was without the latest citizen science observations coming to GBIF. So I'm sure that's well over 50, 60 million already in 2025. I mentioned that we track the data use. The use of GBIF mediated data by you, the community, is growing every year. We just had our latest update for the first half of 2025. The data has been analyzed, and we're on a track to over 2,500 peer-reviewed publications this year. I didn't get the slide updated in time, but now we can officially say that every day, over 7 peer-reviewed publications on average are published that use data from GBIF. And most of that data, most of those data uses will be using collection data and collection data from the United States. So I would imagine at least 6 peer-reviewed publications every day that cite collections data from the United States. And you certainly can go to your dataset page to see exactly which papers are citing the data in your collection. As far as data use, historically, the US has been the largest user of GBIF data by the metric of peer-reviewed publications. China overtook the United States, I think it was in 2023, as the highest user of publisher of peer-reviewed scientific publications using GBIF data, and has been leading ever since. But the United States is clearly the second largest user of a peer-reviewed publishing of peer-reviewed publications using GBIF data. So we track not only peer-reviewed journals, we also track such as things as IUCN Red List. And if your data you share with GBIF, if you go to your dataset page, you'll be able to see if there are IUCN Red List assessments that use the data from your collections. And I hope they do, and I'm sure you'll be able to find examples. I'd like to spend the rest of my talk talking about collections themselves in a project that we took over from the US, from a data set from the Smithsonian National Museum of Natural History, the Global Registry of Scientific Collections, because this is our database that tells us about collections and what is stored in collections. But it's also a great example of collaboration because it is a global collaboration, including with iDigBio and Index Herbariorum. So if you go to iDigBio, page, you might see a map like this. And this is a map of all the collections in the United States. If you go to GBIF, you can get a similar map like this. And this is all the map of the collections from in the US. This is coming from the same data source. So iDigBio in the US and in GBIF, we co-manage a database that contains all the data about the US collections. And of course, the GBIF registry contains data from collections all over the world. But by having a shared registry, this makes things less complicated. We can just update data in one place, and it also streamlines and it reduces costs as well. So this is one of the value propositions of GBIF, is that we can maintain this infrastructure for this registry, and iDigBio didn't have to support that cost. But I also want to point out Index Herbariorum, which of course has been a wonderful leader in developing databases on the herbaria locations and metadata about herbaria. And our GR cycle accesses data from GBIF, from Index Herbariorum, and any edits you do in Index Herbariorum come directly to GBIF and get inserted into the GBIF registry as well. So it's a great collaboration with Index Herbariorum, which is, of course, a huge knowledge base on herbaria. So this is the numbers on GR cycle. This database has been growing rapidly. We now have over 8,700 institutions and knowledge and over 10,000 collections. The data that comes to GBIF comes in data sets, or iDigBio speak record sets, and these aren't one-on-one aligned with collections. But what we've done is matched the data sets to collections as well as we can, and we have nearly 250 million specimens in GR cycle that are attached to collections through the registry. And this is a database that's been edited by the community. It's managed by country editors, and we have 125 information about collections in 125 countries. This is the data from the US, nearly 2,000 institutions with over 2,400 collections, and also over 400 US federal collections. GR cycle originally came as an idea to manage partly US federal collection data, and there's a large data information about where the federal collections are. There are 4 country editors, one that's on this panel, and at least one more that's in the audience. And these are people that manage the data in GR cycle for the country. However, if you are a manager of a collections, you have editing access to your own data, and that's what we would like to do, is to invite all collection managers to manage the data within GR cycle of your own collections, so that we can keep it as up to date as possible. And in the US, over 87 million specimens have been correlated with these collections. That's a third of the global collection. So I'll go briefly through the institution. So this is some screenshots of the institution page on GR cycle, taking the example of the Smithsonian National Museum of Natural History, which is the largest institution with an estimated 100 million specimens. There's a map of the digitized collections that's shared with us, and then a list of the collections within this Natural History Museum that are shared with GBIF. I think there are 11 or 12 different collections within the institution. This is a collection page of the New York Botanical Gardens, of course, which is the home of Index Herbariorum, which is why I wanted to use it for this example. The collection information that is shared through GR cycle is simple locality information, the estimate of the number of specimens, and then the simple descriptions of the collection, taxonomy, geographies, and etc. But there also are other information shared within GR cycle, such as something called collection descriptors, which I'll get back to in a couple minutes. But the collection descriptors allow us to describe collections in more detail, especially of the collections that are not digitized. And Index Herbariorum has been managing these type of collection descriptions for many years, and it's a great source of new data for describing collections through this mechanism. So the herbarium itself at the New York Botanical Garden, this is a screenshot of the collection there, and you may see underlying the dashboard. So what we do, if you have data shared with GBIF, with our infrastructure, we can perform and generate all sorts of different dashboards to show you information about the data that you have shared with us that might not be possible with your own infrastructure within your collection. So pay attention, because there's going to be a quiz at the end of this slide, or at least a trivia contest. So taking the data that's shared with us from New York Botanical Garden, we know that there are, of their 7 million, nearly 8 million that have the collection, they have digitized over 5.1 million, which is a fantastic rate of collections. And those account to over 200,000 separate species. And these have been collected from between 1688 and 2024, according to the records shared with us from the New York Botanical Garden. And this is a histogram that we can put together with that type of data. Next, we can look at the data richness. Of course, the data on collections can be variable. Older collections have less comprehensive data, but this is the rate of identified to species, how many of them have coordinates, year of collections, a little bit of a dashboard of the overall impact of the collections. And this is a very high quality collections. But I would take that sequenced equals 0 to heart, because I'm sure that's just because we don't have that data in GBIF, but many of those have been sequenced, but that would be, of course, an ultimate goal. All right, so that's my quiz. So of the data shared from the New York Botanical Garden, which countries do you think those specimens come from? Top 3. And of course, I can't see you, so I can't see your responses, but the US is number 1. Number 2 is Brazil, and number 3 is Canada. The data shared with us, we can look at the metadata from that collection and identify the US, Brazil, and Canada as the top 3 countries for locations. And again, we can look at the identifications on specimens at the New York Botanical Gardens and see that Lindemeyer has identified over 89,000 specimen identifications at the New York Botanical Garden. Fantastic amount of work. And then Rupert Barnaby, a legume taxonomist, with nearly 40,000. And this is the type of information that you might find interesting for your own collection that we can spin out these dashboards. A specimen record in GR cycle is very similar to a specimen record in iDigBio or in GBIF. It's the same data. It just looks a little bit different because it's formatted a little bit differently. The summary has taxon, location, occurrence data, the usual type of information with a specimen record. One thing that we're able to do with GBIF mediated data is that we have information about specimens across many different collections. So we run an algorithm. If you want, you can call it AI. And what it does is it looks for similarities between occurrences between different data sets. And this little bubble diagram on top there shows that there are 6 occurrences in GBIF that have some similarity to them. And digging into this, we can see that there's a specimen here that was is stored at the New York Botanical Gardens, but there's also a duplicate of that at the Bell Museum in Minnesota, and it has the exact same accepted species name, same date, same coordinates, same country, the same identifiers overlap. So most likely in the field, during a collection event, there was a duplicate was collected and sent from New York to Minnesota. The second example is kind of fun too, because it's only 2 different records, but one of them is an iNaturalist observation, and the other is a specimen record at the New York Botanical Garden. So the collector in this case took an iNaturalist observation, made that, sent that into iNaturalist, and then made a specimen of that, and that specimen also includes the DNA sequence from a 16F sequence of that particular fungus. But what about the undigitized specimens? This is kind of the big question. We have a biodiversity crisis. Can we optimize our digitization programs to make them as efficient as possible? And can we understand where the specimens are that we need to digitize? And we can do this perhaps through the use of collection descriptors, as I mentioned earlier. So I've shown you some of the power of occurrences and the data that I have in them. I also showed you the information that we have about collections. So collections descriptors is about finding the middle place between these, taking free text about collections and the structured data of occurrences and finding a middle ground that describes what you have in your collection that's not digitized. And the best example of this is probably Index herbariorum, which has these tables in them, which describe the algae, bryophytes, and seed plants stored in the various herbarium. So what we done is taken these tables and turned them into standardized data. if you look on top of the first column, it says LTC object classification name. That's the Latimer core, which is the standards for collection. Object classification name is the name for that standard. And by using these types of standards, we can describe and actually at GBIF, we index against some of these standards so that you can actually do searches across collections for certain taxa, even if they're not digitized. So some of the collection descriptors we're working on now, these kinds of searches can be done by recorded by the collector. And they also we're working with the community to develop collection descriptors, the Latimer core community, for other different types of the collections, such as object classification and biome type are the two we're working with currently. What this means is that you can go to a GR cycle, as I did here, and within the US collections, I could search for all the US collections that have bryophytes. And I was able to find 88 collections that state in their collection descriptions that they have bryophytes. It's probably an underestimate, but that's what we have, the knowledge of the data that's been shared with GBIF about these collection descriptors. And I'll put into the chat afterwards how you can share collection descriptors and data through sending us tables of information that correlate with these collection descriptors. And even these, for example, here, the Bessie Herbarium in Nebraska estimates they have 10,850 bryophytes. So this type of table can be downloaded, and if you're a bryophyte researcher, hopefully that would be useful for you. We also our lead on this program, Marie, did a collection descriptor on vertebrates. So she basically looked at all the vertebrate collections in the world all the collections of the world that have the word vertebrate in the title, and gave them a yes for a vertebrate in the in GR cycle. So I used that collection descriptor and identified 123 collections in the US that have vertebrates. Of course, this is probably an underestimate as well. What I'm trying to show you is the power of these standardized ways of sharing your data, undigitized data information, metadata with GR cycle. And then if we're able to do this on a kind of a countrywide level, we'd be able to really understand what we have in our collections. So we have a program called Hosted Portals, which allows an institution or a country that shares data with GBIF to get that data back through a free web page. We have a collection page for US collections for the US, and I hope that at some point we can make this a public page showing and highlighting all the US collections, but currently this is not a public page, but all this information is found in GR cycle itself. And if you are an individual institution that shares data with GBIF for a collection, please consider a hosted portal. We currently have 52 hosted portals, but we don't have any from the United States. This is the one from the Beatty collection in Vancouver. It has all the information that's shared with GBIF about the Beatty collection. And it's a free webpage about that collection that is available for all visitors to the museum webpage. So please consider that. I just want to close by putting a plug in for a conference that we are co-hosting. GBIF is co-hosting with Hedwig and Gioban and Obis in late October in Bogota. It's called Living Data. This is going to be a fantastic conference taking biodiversity information from data providing, standards, aggregation, and use. And I hope you're able to attend this conference, and I'd be happy to put a link into the chat. Thank you, Libby.
Thank you so much, Joe. Lots of good information there. And yeah, if you want to put some of those links in the chat, that'd be awesome. I'm now going to, actually, before I pass it on to Katie, I'm going to just remind folks that we have, let me think, 2, 4, 5 speakers today, and then a bunch of time for Q&A at the end. So if you'd like to put a question in the Q&A using the Q&A feature of Zoom here, please go ahead and do so, and we could answer it as the webinar progresses here, and also we'll have time for discussion at the end. So just want to give folks sort of a little lay of the land here. And with that, I'm going to pass it on to Katie Pearson from Symbiota.
Thanks, Libby. And thanks also, Shyla and Joe, for those good introductions and information about GBIF. We love GBIF. All right. Can you see my screen?
Yeah, looks good.
Thanks. Great. Well, thanks for inviting me to this webinar. My name is Katie Pearson. I'm the project and data manager for the Symbiota Support Hub, which I will briefly explain. And I am here representing and talking about Symbiota, and specifically how Symbiota can contribute to continuing biodiversity specimen digitization. And we'll have a webinar focused on Symbiota in December. So if your interest is piqued by this part of the webinar, please do join us in December for our full Symbiota webinar, where we'll go into more detail. So Symbiota is just an open source biodiversity management and mobilization software. It is on GitHub as an open source software, and we currently have I think actually we're over 2,000 collections currently use Symbiota as either a way to share their data or to manage their data as a collection management software. There are about 60 Symbiota web portals in play throughout the internet. And Symbiota portals are used to mobilize pretty much about 95 million occurrences and growing, and a lot of images to boot. So I am part of the Symbiota Support Hub. We are a development and support team for Symbiota portals. We're based at the University of Kansas, and we're currently part of iDigBio, though we are going to continue to exist even when iDigBio comes to a close. And we host many of the Symbiota portals that you may be familiar with online. And we provide help desk services. We also help direct the development of the Symbiota code. It's open source, so anyone can contribute to it, but we make sure that all of that code is secure and on target. So Symbiota is a software that is used to create web portals for accessing data, very much like GBIF hosted portals, but there's a lot more functionality built in for editing and contributing to the data. So these are a few examples of portals that are very popular. There's the SciNet network. This is a network of about 500 herbaria, most of them in the US, but that's increasing and growing. We have many collaborators from Canada in there as well. There's a consortium of lichen herbaria. We have ecdysis, which is for arthropod collections, mostly insects. And then there's many, many other portals available for different taxonomic or regional groups. So I'm just going to show you, showing a picture tells a million words. So this is a Symbiota portal specifically for the consortium of California herbaria. And the public can use this portal as a search interface. You can see there's many collections that are shared in this particular portal. You can do sharing and searching based on specific criteria. You can do map searches. You can view individual records, leave comments, view any linked resources or associated images if there are any. And then there are lots of other features such as checklist features. You can do image searches and other things for the public use of the portal. As I mentioned, there are about 2,000 collections that use Symbiota portals to mobilize their data. These are just some kind of a physical representation of US collections that share data in Symbiota portals in some of our major portals that the Symbiota Support Hub specifically hosts. Symbiota has been essential for digitization projects across the life of iDigBio. So I think we calculated that 75% of thematic collections networks, which were collaborative digitization projects under the Advancing Digitization of Biological Collections program, used Symbiota in their workflow. So these are a few of the thematic collections networks that used Symbiota, and many of the portals that they launched are continuing to work today. So Symbiota portals are really excellent for collaborative digitization and individual digitization. So a Symbiota portal acts as a central data commons for accessing a consortium or a specific project's data. And you can actually have multiple projects working in the same portal. They would just share some of the central resources like the taxonomic thesaurus, the species pages, and things like that. So Symbiota portals, like I said, they're very much like aggregators in iDigBio and GBIF, but they are much more because they're additionally a collection management system for any collection that chooses to use it as such. So that means that there's data entry, data editing, label printing, batch uploading, batch downloading, searching, all sorts of functions that you would normally find in a collection management system. Right there in the Symbiota portal. So it's web accessible, and you can provide and revoke access for multiple editors and administrators in your collection. Symbiota portals also have lots of great tools for leveraging the activities of your community. So for example, in the herbarium world, it's very common to have specimen duplicates. So there are functions in the portal that can leverage that duplicate specimen data, and you can use it to import that into your collections. So for example, if another collection has already georeferenced a specimen, you can look up whether there's a duplicate in that portal, and you can bring in that georeference data into your record so that you don't have to do that georeferencing from scratch. Speaking of georeferencing, if there aren't any duplicates available, then there are integrated tools for georeferencing. This screenshot is showing a geolocate integration, but there's also integrations with OpenStreetMap so that you can view that and the layers that may be available in OpenStreetMap. Also useful for collaborative digitization is the fact that Symbiota has crowdsourcing and volunteer-focused tools available. This has been widely used by specifically the global consortium of lichens and bryophytes, as well as other collections. I think the Mid-Atlantic Herbarium Consortium also has used this, where you can have users create an account and then they have access to the crowdsourcing tools, which allows them to do data entry in kind of a more contained area of the portal. And then those edits can be specifically reviewed, approved, and made instantly available in your portal. Symbiota also has easy upload and download options, and the data are aligned with the Darwin Core standard so that the data can be easily sent to other aggregators. So there are built-in publishing tools to GBIF. I don't remember, but the last tally is several hundred collections are publishing their data to GBIF directly from their Symbiota portal. They don't have to go through any other avenue. And then iDigBio also harvests data directly from Symbiota portals to put into the iDigBio portal. So all the digitization tools in these portals have enabled thematic collections networks and other digitization groups and just individual collections to create workflows that rely on the Symbiota portal's tools and the efficiencies therein to do really fast, efficient, and sometimes remote digitization work. This is just a screenshot of an example workflow from the California project, But you can see that a lot of the activity happens directly in their portal. So they're able to do their data entry and editing, transcription georeferencing, scoring the phenological status. So that's adding a trait information into their specimen and doing quality checks. That all happens in their portal. And even if a collection is fully digitized, first of all, congratulations, that's a huge feat. Even if it's fully digitized, there's additional layers of data that can be added and that can help with research, education, and other initiatives. We call this extended specimen data. So that's things like trait information or links to genetic sequences, links to field photos or studies that have used those specimens. That data can also be linked on Symbiota portals and made accessible for the wider research and greater public. So at this, I'll just conclude saying that it's fairly easy to join existing Symbiota portals and immediately be leveraging the portals for your digitization needs. You can look at a list of Symbiota portals on our website. As you can see, there are a lot. And then you can also leverage our how-tos and tool documentation in our fully fledged documentation site called Symbiota Docs. So there's a lot of resources available for you to use as you start your journey. And that's also why the Symbiota Support Hub is around, because technology is really hard to start with. And so there are some humans on the line who can help walk you through any questions you may have or challenges that you encounter. So with that, I want to say thanks again for joining this part of the webinar, and I'll turn it back over to Libby.
Super. Thank you so much, Katie. Hopefully you guys are starting to see with some of these services that all your bases are covered. So thank you to Joe and to Katie for just demonstrating that so well. And I think Teresa Miller here from Specify is going to continue on that track. So welcome, Teresa.
Hi, thank you. Thank you for inviting us. Can you hear me just fine?
Yeah.
I usually use this when I'm not here, so I just want to make sure. Share. So we will have a longer full webinar in January as part of the series that they were talking about, January 27th, if anybody's interested. But just for a quick overview of Specify, I'm Teresa. I'm with Specify Collections Consortium. We've been providing collection management software for natural history collections for over 30 years now. And recently we branched out into supporting geology collections as well, so we can support the entire institution and make it easier for the entire institution to be supported. So we are used all over the world. We're currently in 25 different countries with members ranging from a few thousand objects in their collection to nationwide consortia or government organizations. Specify is a cloud-based open source relational software for every type of natural history and geology collection. We provide highly customizable software for documenting, editing, searching, sharing, securing, cleaning, and integrating your collections data, which honestly is something Symbiota can say and Arctos can say as well. We all kind of do the same thing and talk to each other. But I want to just kind of talk about how Specify does it maybe a little bit differently than the other collections. But I think between the three of us and Taxon Works, we're all pretty welcome to supporting if you have any issues or questions. So the first one I want to talk about is Specify's a relational database. That means that every major part of your record or your data is its own record. So agent, taxon, locality, collecting event, those are all their own individual records, which can then relate to another record. And this is extremely helpful for your digitization because it means that you only have to enter a major point of documentation once, and then you can relate other things to it. You only have to update it once and everything else gets updated as well to help streamline the data entry process. And it helps reduce the likelihood that things will get out of sync. The next difference is Specify is highly customizable. And that's been the intention since Specify started. So we want to meet collections where they are really and help support your individual workflows and how you want to get your data through and documented. We have thousands of fields in our data model that you can use. And most collections only use a very small handful, but the opportunity and the options are there for anybody who wants to use different fields to document their data. And then our data entry forms can be customized to accommodate what you do and how you enter your data. And in fact, it can be customized per collection and per user. So if you have volunteers coming in and you want them to see slightly different forms, you can modify the forms just for those volunteers to help streamline the data entry process, to help eliminate the chance that they're going to mis-enter data or enter data into fields they're not supposed to be entering data into. You can also share these data entry forms between different collections so that you can streamline all of that as well and make it an easier process for everybody to get into Specify. We also have conditional forms. Now we created this specifically for geology collections, but it works for natural history collections as well, because it means you can have different forms within your single collection. So if you have a collection that has nests and birds and eggs, or if you have a vertebrate collection that has fish and birds and mammals, you can have different data entry forms for each one of those, all within the same collection, which means you only have to set up one collection, you have all of your permissions set up, and you can search everything at one time. But when you're entering data, you're only seeing the fields that are relevant to what you're entering. So you can streamline the data entry process and you can really be focused on what you want to enter. To help with the digitization, we've also put a lot of effort into our bulk data entry. So we have the option to clone, carry forward, and to bulk carry forward. So cloning means that your record is going to be duplicated exactly except for the unique identifiers for it. Carry forward gives you more control. It means you can decide which fields or tables will be carried forward from one record to the next. And you can just keep creating those records and auto-assigning catalog numbers or manually entering them as you go. So bulk carry forward means that you can enter hundreds or thousands at once. So if you have an entomology collection and you want to create basically the same record just with a different unique identifier for each one for all 300 of the weevils that you collected, you can do that with just a few clicks. You can do that by either entering a range of catalog numbers, or you can do it by saying, I want to enter 300 records, and Specify will automatically create those for you. Another way we have to bring data in bulk to make your digitization efforts a lot smoother and faster is our workbench, which is a spreadsheet-based application. So you can bring in a spreadsheet of data, hundreds, thousands of records at a time, and you can say this column matches this field. I want the data from this column to go into this field, and Specify will check it and make sure that the data matches your database requirements. So if you have a date field, it'll make sure that the data in that column matches the date requirements. And it's a valid date. If you have a formatted field like a catalog number, it'll make sure that it matches the format. Same thing for a controlled vocabulary. Now, while it can't do that for things like agents' names or taxon names, it will tell you this is a new one. So before you even bring your data in, you can go through and it'll warn you, are you sure this taxon should be new? Or did you want it to match something that's already in your database? To make sure that your data is as clean as possible when you're bringing it in. So when you share your data later on, everything is the way you want it to be and reflecting how you want your data to look. I should also mention that's also a way you can bring in new outside data, such as new citations. So if you went through and you scrubbed for citations, you can bulk bring in hundreds, thousands of citations to your work and just attach it or reference it to your existing collection object records. If you sent out several specimens for DNA sequencing, you can bring in those DNA sequences and link them to your existing records. So Just with a few clicks, you can bring in all of that data. But anytime you bring in data, because we're human, there's always issues. If you don't have issues, I don't think you're human, it's fine. Everybody always has issues that they need to clean up. So we have tools for helping you clean your data to make it easier for you, such as batch editing, where you can bring in fields of your data, specific fields, and clean them up, and then bring it back in. We also have record deduplication, because inevitably, always, you are going to end up with more than one of certain records, like people. You're going to end up with an A Bentley, an Andy Bentley, an Andrew Bentley, an AC Bentley, and you're going to want to merge those. And record deduplication allows you to do that. It also gives you metadata about that information, like when were they collecting, so you can make sure actually AC Bentley is somebody different than Andy Bentley, and not merge those, but merge everything else. So you can make an informed decision when you're cleaning up your data. Another thing we have to help you with the process is we have a visual hierarchy of taxonomy, geography, storage, lithostratigraphy, chronostratigraphy, and tectonic units. So you can visually see where everything is and that it's where it's supposed to be within that hierarchy. This is also a way that you can go through and merge, synonymize, and move things, and you can see immediately what that effect is. And because it's a relational database, that means that anything linked to what you moved will reflect that change. So for example, if you synonymize a taxonomy, any collection objects pointing to the original one will be able to say, it was originally determined to be this, but the accepted name for that, the synonymized name, is this in your record. And you can search for it, and you can see it in your records. Like I said, we're very, very customizable, but that doesn't mean that you can't export your data and share your data. There's a lot of effort and thought into how you can export your data. We abide by Darwin Core Standard terms that Tadwig sends out. So you can share your data with aggregators like iDigBio, GBIF, GTN, Symbiota, Obis, basically any aggregators. You can send your data out to make sure that your data can be ingested easily by others. You can also export your data in any fields you want to through multiple methods and specify. So you can create CSVs, TSVs, Darwin Core archives, KMLs to share your data how you want to. Specify what we're doing this. You can be extremely secure about it. We have a role-based system, so you can have different permissions for different people. So again, this is a way to make sure the data is getting entered how you want it. So if you have volunteers that you want to have more limited access, you can give them more limited access. And you create a role to say any volunteer coming in has these permissions, and you can edit it for individuals to say, but actually this one has been working with us longer. We trust this person, they can do more. You can also, we give you a way to see your collection by the numbers. These are pre-programmed numbers that you can edit and you can add to or take away from at any time, so you can quickly see what's going on in your collection. And it can help you understand where you are in your digitization efforts. So you can see what percentage has been imaged, how many collection objects have images. You can also add numbers for how many aren't. And if you click that, it will take you to which records haven't been imaged yet to make it easier for you to figure out where you want to start. You can see the percentage georeferenced, which ones haven't been georeferenced, which ones have, the percentage that have been imaged. So you can easily see everything. So for our upcoming development, we have a lot of plans. We always do. We have more plans than time, but the immediate upcoming developments are, we're creating a guided setup so our members can create their own collections and their own databases. We're enhancing the data export functionality. Like I said, you already can export your data, but we want to make sure it's as easy and user-friendly as possible. So we are changing or updating it slightly to make it a lot faster for you. Same thing with the API improvements. You can already use the API to bring data in or send data out in bulk, but we're improving it even more so you can do more with it. Improved barcode support, so you just have to scan something to make it easier. And we already support barcodes, but we want to make it more so for you, make your jobs easier. and sharing schemas, so you can standardize between collections if you want to make it faster for you. So, thank you guys very much. So I think I went over 10 minutes, I'm sorry.
No, that's great. We have some time at the end to work with, so we have a little flexibility. Thank you so much, Teresa. And before I pass it on to our next speaker, I want to remind folks about the Q&A feature. I know a few of you have posted in there already and gotten responses from some of our speakers, so thank you to both participants and speakers for taking advantage of that. I also want to emphasize the sort of unique opportunity we have here, having all of these different platforms represented in one place at one time. So if you have specific questions, no matter how deep in the weeds you think they might be, feel free to just put it in the Q&A and we could have our speakers address them. Or if you're totally new to this and just have a really basic question that may not have been addressed, feel free to put that in the Q&A too. So this is kind of like whatever you might need, we could accommodate here. So thank you, Teresa, again. And now moving on to Emily Breaker from Arctos. Hello, Emily.
Hello, let me share my screen here. Good afternoon, and so good to hear from my fellow panelists on all the tools available out there. Can you see that okay?
Yeah, looks good.
Great. All right, well, thanks so much for having me. My name is Emily Breaker, and I serve as the Education and Training Officer for the Arctos Consortium. So in thinking about today's theme on sustaining motivation around digitization, I did want to start with this slide just to remind us of the many opportunities gained when mobilizing collections data. So accessibility and usage are the major drivers in making our data more widely available and of greater utility to diverse end users and applications. But digitization also helps us to manage, preserve, and document our physical holdings. And it's an additive process. So by sharing out our data, we can receive useful feedback as well as engage with technologies not possible with analog formats. And digitization promotes broader impacts, not only from the incredible science coming out of our collections, but also from educational collections advocacies and workforce standpoints. So Arctos really supports each of these areas. So I'd like to use this time to highlight how it does so, while also streamlining various aspects of digitization, especially in the face of potential funding cuts where institutions may find themselves seeking out increased efficiencies. So just briefly, Arctos is home to over 5.6 million records and 1.1 media objects spanning bio, geo, and cultural collections. So from algae to zooplankton and many diverse collection types in between, Arctos provides a comprehensive platform to manage, host, and link collections data. The Arctos model performs much of the heavy lifting in terms of accessibility and data management. So as a web-based platform, operators don't need to maintain their own servers, configure software or backups, and collections data are made publicly available through the Arctos portal. Arctos data are securely hosted by the Texas Advanced Computing Center and backed up on tape, as well as replicated on a mirror at UC Berkeley, safeguarding against data loss from disaster or cyber attack. And Arctos provides free media storage, supporting collections in mass digitization efforts and hosts media of all types. And it's a robust solution, particularly for institutions without a storage infrastructure that rely on less sustainable systems like hard drives or local servers with limited IT oversight. And Arctos can interact with institutional or external media host providers. And Arctos uses a highly structured schema where database fields are already mapped to the VertNet IPT and pipelined to data aggregators via Darwin Core archives, or as Darwin Core archives. So operators really only need to opt in to data publishing rather than set up and manage their own IPT. So really taken together, these features significantly reduce the technical burdens on museum staff. The Arctos platform is unique in that it leverages a shared data environment. So wall collections have ultimate control over their data through a virtual private database model. Terms like people and taxonomic names, localities, and controlled vocabularies are co-curated across institutions or pulled in from authorities. So in this environment, duplication is minimized, search precision increased, which leads to more discoverable data, dynamic connectivity between records, and many efficiencies. So for example, Arctos displays a system-wide view of all records and actions associated with individual agents. And these profiles can be collaboratively edited so that operators at one institution may add details like birth and death dates that help other users corroborate low-resolution identities within their collections. Diverse taxa collected on the same expedition or even the same locality resampled through time share locality IDs instead of partitioning or duplicating this information into separate records. And shared localities also enable batch georeferencing for historic collections. And only one person needs to pull in a publication DOI for anyone else in the system to be able to access that record and add their own collections, specimen citations to it. Another shortcut is the ability to easily clone information from existing records, both within and across collections and institutions. So for instance, if you want to replicate core occurrence data when cataloging casts separately from fossils, or when splitting co-collected taxa from the same event into separate collections or even to totally different institutions, or when duplicating data from host vouchers to create the corresponding parasite records. And so this feature was used by the Museum of Southwestern Biology during their terrestrial parasite tracker TCN project to pull in details from over 16,000 mammal records housed at multiple institutions to rapidly catalog more than 50,000 parasites. And of course, that saved them a lot of time and reduced transcription errors. Beyond basic data capture, Arctos provides digitization tools to increase data connectivity. So for instance, users can tag specific areas within images and PDFs, like these individual chipmunks within a drawer, or different ledger or field note entries in order to visually associate that information with the relevant specimen records and easily navigate between the resources. And so this is a really good task for staff who might not have the budget to necessarily take on a new digitization project, but might still have the capacity to enhance existing media already in the system. And media can be uploaded to Arctos independently of records, which helps facilitate primary metadata capture for collections whose workflows involve databasing directly from images. Another way to augment data already in Arctos is to create thematic project galleries, with each page acting as a website to track and share digitization or research project activities, including summaries of personnel, catalog records used or generated by a project, and resulting media and publications. And these pages can be shared with the scientific community, with funders, and/or public audiences. And many institutions use project pages to collate data for reposited collections that they've digitized. So like national park specimens for folks here in the US. And that provides an easy way for agency collaborators to see all of the public land holdings without having to perform multiple queries. Each Arctos record dynamically summarizes object data with hyperlinks to all areas of the database, like agent profile pages, taxonomy, and transaction details, as well as supports link outs to extended specimen products like journal articles, genetic sequences, data and media hosted in external repositories, and corresponding occurrence record pages at the aggregator level. So this is a record from my collection, which highlights the flexibility of the model in hosting media from multiple sources. So we have JPEGs of the snake uploaded directly to TAC, the CT scan of the head that's hosted on Morphosource that's pulled in via API, as well as a scanned ledger page linked to a server located at our campus library, which hosts our museum archives. There's also several bots available that detect and link digitization products hosted in external repositories to automate digitally extended specimens. So Morphosource and GenBank tools search for identifiers relating back to Arctos specimens, saving managers from tracking down these data products that can go often unreported by researchers to loaning institutions. There's also many fully and semi-automated georeference tools available for adding coordinates to localities, as well as a bot that searches for unreciprocated connections between records and hyperlinks the related specimens so that they're easily navigated to and from one another. And in terms of current and future directions, there's some new developments that benefit both Arctos operators and end users alike. So we have an assistive chatbot tool in beta that's developed by grad students at UC Davis that leverages natural language processing for queries. And we're also working on an Elasticsearch portal, which uses indexing similar to faceted online shopping filters, customized for different collection types. Arctos supports the use of data via web services, so we have API keys available upon request, and an Arctos R package that was developed last year that performs complex queries to the Arctos API and automates several common data workflows. And then we've got several media upgrades in progress to integrate with digital asset management systems and IIIF standards, and add functionality like tiered accessibility for sensitive media such as sacred cultural objects and transaction documents, and enable user-curated galleries where people can build their own thematic media collections. So stay tuned for those developments. And then finally, I just wanted to end with talking about our community. So Arctos is a highly active and collaborative group due to our shared data model. So as a result, all development and governance is community driven by on-the-ground collections staff. We meet twice a month and we have several focus committees working on different nodes of the database. And this cross-institutional, cross-disciplinary collaboration is the greatest strength of Arctos. And I think a lot of people in our community find it deeply valuable to work together on data structure and simply to connect with other professionals to see how people approach and manage various aspects of digitization. So there's a lot of support, whether you're new to Arctos or a longtime user trying out a new feature or integrating an unfamiliar collection type. So with that, I'll wrap up, and here are some links to access Arctos, to learn more, and to get in touch. So thank you.
Thank you so much, Emily. Last but not least, we have Matt Yoder from Species File Group.
I think I can replace the current share. Share. Can you see that okay?
Yeah, looks good.
All right. So I'm going to take a bit of a different tact. I think what we've heard from Symbiota, Arctos, Specified, GBIF, we're all on the same page, as others have already noted. And so I sort of want to blather on a little bit about more on the what should we be thinking about on the major motivations for continuing biodiversity specimen digitization. So my name is Matt Yoder. I am a taxonomist by training and now a biodiversity informatician leading an endowed group called the Species File Group here at Prairie Research Institute, University of Illinois. We have three major projects that we work on: the global names architecture. So if you've ever used the Biodiversity Heritage Library, all of that nice name indexing comes from that effort, and many other name detection tools come through the global name. We are one of the largest providers of data to the Catalog of Life. Many of the software packages that you've seen are using Catalog of Life APIs through Checklist Bank, and those are only going to be growing and becoming more important. So we feed a lot of data directly from TaxonWorks or through TaxonWorks to the Catalog of Life. And of course, we work on TaxonWorks, our workbench that was originally sort of geared more towards monography and sort of systematic biology, but we largely figured out that we should be in collections because that was the kind of data that we all needed to reference. And so we sort of put the two side by side, and we are currently seeing no indication that digitization is slowing down in the US. We're seeing hundreds of thousands of specimens pour into TaxonWorks through our GBIF, through our Darwin Core importer and through just normal curation practices. But what I really want to sort of talk about is step way back and be a little bit philosophical and ask why we digitize. And I want to propose that there's three categories of why we do this. One is sort of the tricorder Star Trek future, where we're really trying to chase new technologies. We really want to go out into the field, take our little tricorder device and sort of digitize in situ, right? We'd rather not disturb life by killing it and bringing it back to the life if we can understand what we need to know about life there in situ. And so there's a whole bunch of sort of science and technology reasons for continuing to digitize and continuing to think about digitization that have to do with this tricorder sort of area. The other major area is sort of this El Dorado. I originally said diamond mine, but that's not very sort of politically correct. So the El Dorado, the lost city of riches, right? And here's where we go down the path towards ideas of bioeconomy, science for citizens, and citizens for science. And we're truly trying to figure out how we can add value through the digitization process. But I really want to kind of focus and not really be aggravating, but I really want to say, why do we want to keep digitizing is because we don't really know how yet. And I don't really mean that we've failed to digitize. There's been incredible work through iDigBio. You've heard incredible work for all of these providers. What I want to say is that we're really at our infancy with respect to when we've started to digitize versus when we started to collect. And I feel that that overlap is going to be really key in the future. So I don't know if you can see my mouse or not, but if you look at where we're at today, the red line on the top here, we've only been digitizing since 1969, I think, when the Smithsonian first took some punch cards and added some digital data and added 11,000 records into their mainframes. And we've been, collecting since much longer, right? And we've been adding specimens for a much longer time. So if we think far off into the future, we really want to be at this point where we've been collecting and digitizing for the same amount of time, right? Where these two periods of time overlap. And why is that important? I'm going to argue. I want to say that that's important because our understanding of the processes and the things that digitization are really valuable for only come between that interplay of our collecting layer and our digitizing layer. It's the processes that kind of merge those two areas that bring out understanding. And so why digitize? Well, we haven't been doing it for long enough, and we've got a lot to learn, I would argue. And so I just want to highlight two different quick examples of what I mean by processes and what I mean by learning. And I'll touch on one or two other things. So these are slides that many of you have seen from the spinach talk, and they reflect that the process of digitizing is leading to certain kinds of data. And those certain kinds of data and scenarios are causing us as developers or as people or as users to scratch our heads and go, wait, we've got more work. So for example, you heard the Arctos folks are adding identifiers to people and they're using those people across all the projects. Wonderful. Well, what happens? What identifiers? If we go and look at very famous people now and Linnaeus, we see that there are, on Wikidata, there are over 196 identifiers for Linnaeus. So we immediately have created this situation in our digitization frameworks where we've created a bit of confusion, and we can sort of expect this to expand, right? Which identifier do I put in my system in Arctos? Which one do I, as a developer or an R user of R Arctos, how should I try to reconcile all of those identifiers? And that's only emerged at the interplay of digitization and the use of collections. Here's another one. You heard about GBIF from Joe, and it's an amazing resource. We want everybody to use that so that we can draw that directly into our systems. However, same kind of questions arrive. Here's the Royal Ontario Museum. There's 24 different identifiers for the Royal Ontario Museum. And when you go to the website and you search for ROM, you don't actually find the Royal Ontario Museum. So this isn't a fault. It's just something that has emerged because we're aggregating, because we're thinking about how we talk together. And it's because there's this plurality of how we look at data, right? We're doing this in 4 different ways with these platforms. We're digitizing across many different standards, et cetera. And I think there's going to be a whole suite of problems that emerge just because of this interplay. Before I get into this sort of how we're creating interplay, I want to also point out that if you go to any one of our issue trackers, it's amazing that we're all open source. We all have 500, 600, 700, 800 different issues that are open, right? This suggests that our software is not done yet, and our understanding of the processes that are not is not quite done yet too. So how are we in TaxonWorks? We're doing a lot of the similar things. Everybody's on point. It's just amazing to hear these same ideas there. How are we sort of discovering or working in that space between digitization processes? One of the things we're doing is we're sort of creating that extended digital specimen framework, just like the folks in Arctos you've heard, all in one place, where we can do matrices, we can do rich literature, we can do highly granular taxonomic catalogs, and we're putting those in one space. And so if we step back out and we think about the kind of projects that are in TaxonWorks, these are all a sampling of projects that are 10,000 records or more, you can see sort of a spectrum of how it's being used, right? We're not only getting projects about digitization, we're getting some that are completely about traits. We're getting some that are completely about nomenclature, and we're getting some that are, more about georeferencing and checklists. And I think that, to me, why we want to digitize is that by putting these kind of needs together in certain spaces, and then by thinking about, wait a minute, this is not just TaxonWorks, but there's a space between TaxonWorks and Symbiota and GBIF and iDigBio, we're still learning. And so that's all I'm going to say. Maybe a little thought-provoking about it. I will mention that we do an annual conference called together.taxonworks.org. Every May, we're going to do it again, and that you can drop by every Wednesday. Maybe Debbie's dropping links in chat. If not, to our support group if you have any questions. And thank you for including me on the panel, and maybe we'll have some questions from there.
Thank you so much, Matt. That was a perfect ending to our lineup here. Definitely thought-provoking and a little different. So with that, I'm going to thank our speakers, thank our participants, and pass it on to Shyla for some Q&A and discussion. So panelists, if you are around, if you want to sort of tune in here, I believe the questions that have been presented in Q&A have been answered. So I'm going to pass it on to Shyla for some further stuff.
Yeah, just a reminder, if anybody has any questions, please drop it in the chat and we'll go ahead and go through and answer them. Or excuse me, the Q&A feature. I'll give it a couple minutes.
Yeah, and maybe as Shyla's doing that, if I thank you to Joe and Katie and others who have chimed in with some answers to questions. If you'd like to talk about those more here, if those seem like questions that might be on other people's minds, we could take a couple minutes to do that.
There was a question in the chat about error reporting, and it was specifically about GBIF error reporting, but it might be an interesting topic for everyone to comment on. Like, how does someone who's accessing the data in any of these areas like report errors? In GBIF, there's a little like speech bubble link in every occurrence that you can click, and if you click the content option on that, then it actually points you to where you can leave comments on that specific record. Sometimes it's like, okay, email this person, or there are some infrastructures that will take you to the page where you can leave a comment on their infrastructure, and that's the case with Symbiota and I think some others. I don't remember. Is that Arctos too?
Yeah, each of our catalog records, there's a comment or report bad data, and so people can just leave a free text remark in their email, and you'll get a notification in your feed.
Yeah, so on most aggregators, there's some way of leaving feedback or these portals. So, but that's a great question, because that is a part of the digitization process that I don't think we have fully figured out yet, is how to efficiently leave feedback, and for that feedback to be approved or automatically approved, or are we just adding one step to the workflow? So that's a really good thought to just consider for the additional things that we still have to figure out in the realm of digitization.
Thank you so much, Katie. I don't really see anybody dropping any questions in the chat or in the Q&A. If anybody has any of our speakers has any last remarks, maybe a good time.
I'll make one comment. This is Gil. Emily, I noticed that you put some links to stuff in the chat, but I think you sent it just to the panelists. And so
I saw that and I sent it to everyone, but thank you.
okay, all right, good. I wanted to make sure.
Thank you.
Excellent. Thank you everyone for coming. I want to give an extra huge thank you to all of our speakers for giving excellent presentations, and thank you so much to our attendees for coming. So I'll be respectful for everybody's time and let everybody go. Unless anybody has any last minute comments. Oh, I see one. Okay, just a thank you. So go ahead and log off whenever you feel fine.
Thank you all.
Thanks, everyone.
Thank you, guys.